Hi, everybody. This is test 3 review. If you go to the announcements section, I've posted an announcement and say, do the following problems. So I'm in the announcements section right now. It says test 3 review problems. The first one says, go to page 100 and do 4B. So what happened was I went to the test and then I went to this review through the workbook, and I found problems similar to these that are on the test. So when I say page 100, I don't mean down here. No, I mean up here. This is the page number in the upper right-hand corner. Okay, so let's go to page 100, 4B. And it says convert this to a percent. So first I'm going to go from fraction to decimal. And I'm just putting it on my calculator, 11 divided by 12. And I get 0.916666. And then I have to change it to a percent. Changing it to a percent, you just move the decimal two places to the right. So this is 91 if I round it to one decimal place, it ends up being 91.7%. There's another way on our calculator to change it to a percent. And I want to show that on the calculator that we're using for this class. 11 over 12 as a fraction. Here, I'm hitting the ND button and then typing in 11 over 12. Then I'm going to just arrow over. And I want to change that to percent, fraction to percent. And here's the percent button, but this arrow to percent means change this number to a percent number. So I'm going to hit second and then change to percent and hit enter. And there's our percentage, 91.66666%. If you round it to one decimal place, it's 91.7%. So that's the difference. That is second percent button, but this is second changing the number to percent. The arrow means change it to percent. All righty. So the next one is page 101, number 7. So let's go there. Here's page 101, number 7. It says Juan wants to purchase a new CD player priced at $80. This is the price of an item. If the sales tax is 8.25%, that's our sales tax. Find the actual sales tax. So I'm looking for a formula somewhere on here. Maybe the simple interest formula. Juan wants to purchase a new CD player. Okay, so we're looking for simple, just the sales tax. So I'm looking on. By the way, I'm using this formula sheet that I put in. There's lots of. I think I gave you 2 or 3 different formula sheets. I'm going to be using this one because it pretty much has everything on the front and the back. So on the front sheet here, it even showed you how to change from fraction to percent. So from here, we want to find the sales tax. Well, there's an actual formula for sales tax, just in case you don't know. So the formula says sales tax amount equals the tax rate times the original price. So first we want to find the sales tax amount. That's this formula right here. The tax rate was 8.25%. The original price of the item was $80. So when I multiply those two together on my calculator, 8.25%, 8.25, then I hit second and the percent button, times $80, and my sales tax amount is $6.60. So you always take money to two decimal places, $6.60. Okay, so that's the sales tax. If they just wanted to know the sales tax, that's the answer, and they do. Then it says find the total cost of a CD player. Well, the total cost equals the original price plus the sales tax amount. Right? When you go to a store, you don't pay $80 for the CD player. You pay the $80 plus the sales tax amount, and we said the sales tax amount was $6.60. So 80 plus $6.60 is $86.60. So when you go to the counter and thinking you're going to pay $80 for a CD player, you actually have to pay $86.60 because you also have to pay the sales tax. All right, so now I'm going to page 104. 102, 103, 104, and we're going to do problems 1, 2, and 3. The simple interest problems 1, 2, and 3. All right, so problem 1. Max had to borrow this amount. That's our principal. This is our interest rate. This is the time. Time's always in years. 6%. What is the interest he had to pay and the total he had to pay back? So what was the interest? So it's the same formula that we just kind of had. Let's look up the simple interest formula here. So simple interest formula, when you look at simple interest formula, it says interest equals the principal, your starting amount, times your interest rate times your time. So your interest equals your principal, and on here it says PV. So we're not going to use PV. We're just using P as our principal. PV stands for principal value. So we're just going to use P. So our principal value, which is our starting amount, was $4,500. Our interest rate is 6%, and time in years is 2 years. What was the interest he had to pay? Okay, so this tells us what the interest is. I'll multiply those all together. $4,500 times 6% times 2, and the interest added to this is $540. So Max borrowed $4,500, and the interest on borrowing the money was $540. So how much did he have to pay back? Well, he had to pay back the loan, which was $45,500 plus the interest. $4,500 was a loan. $540 was the interest. So he had to pay back, when you add those two together, $5,040. That's how much he had to pay back. Okay. That's question one. Moving on to question two. Elisa had a loan for $600. Her interest rate, simple interest, was 120 days. Well, for 120 days, except we have to change all days, all time. Time is only in years. So, and instead of 362 days or 353 days, 60, however many days in a year, 365, what we do is we just round it to 360 days in 1 year. So time is 120 over 360. If it was 52, if you said, 5 weeks, then it'd be 5 over 52 weeks, because there's 52 weeks in a year. But since we're dealing with days, we call it banker's days, or a banker's year. We just round 362 or 363 to 360. So time is 120 over 360. How much did she have to pay back? So first we have to find the interest. The principal times the rate times the time. Principal was $600. The interest rate was 7.8%. And time in years is 120 over 360 days, which that's 1 year. That now it's in years. Do you see that's 1/3 of a year? So our interest, when we multiply all this together, 600 times 7.8%. I hit the percent sign. Times parentheses fraction 120 divided by 360. And I get $15.60 for interest. So how much did she have to pay back? Once again, she has to pay the original amount plus the interest. The original amount was $600 and the interest was $15.60. So she had to pay $615.60. All righty, let's look at the next one. A loan of $3,500 was made in simple interest for 3 months. Find the loan's future value. We want to find the loan's future value. In other words, how much do we have to pay back? Now, we have the formula here for future value with simple interest. And we're using simple interest because they don't tell us to compound the interest. They don't tell us to compound it. So we know we're using simple interest. So using future value with its simple interest formula, future value equals F, which is the future value, equals the present value, 1 plus R times t. So this is the formula. Our present value is 3,500. Our interest rate was 4.5% in this problem. And the number of years is 3 months out of 12. So you can't just put 3 down, it has to be in years. So 3 divided by 12, now I'm talking about 1/4 of a year. Do you see? You have to change it, because 12 months equals 1 year. All right, and that'll give us our future value of this loan. In other words, how much do you have to pay back? You're going to have to pay back the principal plus the interest. 3,500 parentheses 1 plus 4.5% times fraction 3/12, and I hit enter, and the future value is $3,539, and rounded to 2 decimal places is 38 cents. So our loan was for $3,500, and we had $39 in interest. Okay, so I'm going to page 113 next. And we're going to do 1B. 113 and 1B. Okay, so Maria invests $3,000. This is our starting point, our principal. That pays an annual interest rate of 5% compounded quarterly. So N equals 4. Quarterly means 4 times a year, right? Don't forget, yearly means one time a year. Biannual or bi-yearly is 2 times a year. Monthly, N is 12. Weekly, N is 52. Daily, we use N is 360 for daily, 360 days. Quarterly, N equals 4. Okay, so we're going to do this one after 12 years. Compounded quarterly, how much does it have? So I'm looking for the compound interest formula, and it is future value equals present value times 1 plus the interest rate over N. Now I'm looking at this formula. It says M as in Mike, but in all formulas, it's supposed to be N. So I'm using N, and then raise it to a power. I always put my powers in parentheses. It's N times T. So this is the future value compound interest formula. So we're going to put 3,000 in the account. The interest rate is 5%. We're compounding it quarterly. That means N is 4. This is a 1. And we're raising it. N is 4 times the number of years. T equals 12. So I'm going to put this in my calculator. And you got to make sure you type it in there correctly. 3,000 parentheses 1 plus a fraction. Mm-hmm. 3,000 plus 1 a fraction, right? I hit the ND button to get the fraction. So 3,000, 1 plus a fraction Fraction is 5% divided by 4. Then I want to arrow over. And to get a power, I use the arrow button and raise it up. And I do all my powers in parentheses. 4 times 12. And I arrow over, and we have everything in there, and that's what I get. So if I put $3,000 in the bank, compounded quarterly for 12 years, I end up with $5,446.06. That's with that interest rate of 5%. Okay. Where are we going next? 114, number 1 and number 6, page 114. What happened? How come I can't change the page? What did I do? What did I do? What did I do? I did something. Give me a second. All right, so I'm back. I'm on page 114. Let's do page 114. We're supposed to do problems 1 and 6. Do I have a 1 and 6? Well, I don't even see a 1. Did I mean 3? There's 6. Let me do problem 6 for you. Maybe I just meant 6. It says 1 and 6. I'm going to look at 6. Okay, so find the amount that Juanita should invest. So we're looking for how much she wants to start off with. So we're looking for P this time. And this is our future value. We want to know this. She's going to end up with this amount, but we have to start with a certain amount. Our interest rate R is 8%. Our time is 20. This is R. If interest is compounded quarterly, once a million quarterly, and is 4 times a year. So we're looking for a present value formula. We actually have this formula on another sheet. So I'm going to keep on staying with this sheet that I'm using right now and just show you, even though I'm using this sheet, I can still do this problem fairly easily. I know the other sheet might have a P equals formula. We're looking for a P equals. This one doesn't look like it has a P. It has annuities for future withdrawals, but no, we're looking at compound interest. And the formula that we're looking at is future value equals present value. One plus R over N times NT. We know future value is 50,000. Present value is what we're trying to find. The interest rate is 8%. We're compounding it 4 times a year. Compounding it 4 times a year for 20 years. Time is 20 years. 4 times a year, and time is 20 years. Now, if you look, we're trying to find P. So I'm going to take this whole thing here to the other side. It's multiplying times the P, so we have to divide it by both sides. So I have 50,000 on the other side, and I'm going to divide 1 plus 8% over 4 raised to the 4 times 20. And that gives me P. Do you see? I just divided both sides by this, put that under here, and that's what I got. So I'm going to put that in my calculator. You got to be really careful when you put that in your calculator. It's not easy at all. And since the top only has one thing, we don't have to put the top in parentheses. But I'm going to start off with my parentheses. I'm going to start off by turning this on. Start out with parentheses, and 50,000 goes on top. On the bottom, I have parentheses 1 plus another parentheses 8% over 4. I arrow over, hit parentheses, raise it to a power of 4 times 20. And then I arrow over, and I have everything in there that I need to. Now when I hit enter, that's my answer. So what this says is, in order for me to get $50,000, I need to put $10,255 in the bank and 49 cents, rounded to 2 decimal places. I need to put that in the bank now. So 20 years from now, it'll be worth 50,000. That's what it's saying. How much should I put in the present value to have a future value of 50,000, and it's over 20 years, 8% interest. So if you put 10,000 in the bank now and you get 8%, it'll be worth $50,000 20 years from now. All right, so I'm going to the next one. It says page 116. Page 116, number 3. Okay, in the next 5 years, so time is 5 years. The Campbells want to save 30,000. So they want to, that's the future value. In the future, they want to have $30,000 to pay down on a house. How much they save per month? How much must they save per month? Compounded monthly. So in this case, n equals 12. Monthly is, this is the interest rate. And we want to know the payment. How much must they save per month? So they're making a payment to the bank every month to save money to get $30,000. So on here, you got to look for a payment formula. And I'm on here. It says calculate a sinking fund payment. Parents wish to have $80,000 available, and then it tells them all the rest of the material. So here they want to have $30,000 available. So here's the formula to calculate how much. It says payment, but this is how much you're going to put in the bank every month. It says your future value, how much you want in the future, times your interest rate over, it says M here, but once again, it's N, how many times you're compounded per month, per year. And then it gives us 2 parentheses, 1 plus R over N raised to the power of N times T and then we have a minus 1. The parentheses make all the difference here. So our future value, we want to have $30,000 in the bank. The interest rate is 7.5%, compounded per 12. So that's the top of the fraction. The bottom of the fraction is 1 plus the interest rate, 7.5%, over 12, raised to 12 is it compounded times how many years? 5 years, minus 1, and then close the parentheses. So the number of parentheses is really important. You practice this until you get the same thing I do. So let me put this into my calculator, and I'll show you as I'm doing that. Okay, trying to show you. So I'm going to start off with a fraction, and we're going to I'm going to do a parentheses. We want 30,000 times a fraction, 7.5% over 12. I'm going to arrow over and then put my parentheses. So that's the top. Arrow down. We have two parentheses. 1 plus a fraction, 7.5%, divided by 12. That parentheses is closed. Raised to a power. The power is 12 times 5. Close the parentheses. I'm going to arrow out of there because then we have to do a minus 1. If you do a minus 1 on top, you mess it all up. And then I have a parentheses around that whole thing. When I hit enter, this is what my payment looks like. In order for me to save $30,000 over 5 years, I have to put $413.64 in the bank every month for 5 years, and it will add up to $30,000. Okay, so I'm going to page 119 next. 17, 18, 19. 119, number 1. Okay, we're going to do this one right here. Customer has a choice of 2 car loans. $20,000 is his starting amount, present value. A 3-year loan, so one time is 3 years at 6.65%. The other time is a 5-year loan at 7.15%. Find the monthly payment for each. So let's start with the payment formula. Same formula we pretty much just had. Future value. It's actually not the same formula. It's a little different. See, this is calculating a fixed installment loan payment. They call it amortization on the car, so it's different than a sinking. It's different than a sinking fund. You're making payments on a car. This formula is right here where I have my thumb. Calculating fixed installment loan. Suppose you decide to borrow $30,000 on a new car, 5 years. What are your monthly payments? So we're using this formula here. All right, so it's a little different. I'll go ahead and write the formula down. Principal times the rate times n, the number of times compounded, divided by 1 minus 1 plus r over n raised to the power of negative n times t. And we're going to close that. So, I mean, that's so that's the formula. That's an r right there. Let's plug everything in twice. The principal is 20,000 times the interest rate for the first one is 6.65%. And we didn't say, it doesn't say how often you compound it, but for a car loan, you compound it monthly. You make a payment every month, so 12 times a year. Car loans are always 12 times a year. So that's the top. So I'm putting a parentheses around the entire top. Then I have the bottom, 1 minus 1 plus the interest rate, 6.65% over 12 raised to the power of negative 12 times the number of years is 3-year loan here. And that's that. So we got to find this answer, and then we're going to do the same thing over here. It's a $20,000 car loan, except here we're dealing with the interest rate of 7.15%, and it's still being compounded monthly, 12 months a year. Dividing all this by 1 minus 1 plus 7.15% over 12 times a negative 12 times the number of years for this loan is 5. And we close that parenthesis. So if you don't close a parenthesis, you see each open parenthesis, you have to close parentheses. So we're going to figure this out for each one. Good luck trying to type this in, especially to me. Parentheses, 20,000 times another parentheses, 6.65%, divided by 12. Arrow over, close the parentheses, take it down to the bottom. Parentheses, 1 minus parentheses, 1 plus fraction, 6.65% over 12, arrow over, parentheses, raise it to the power of negative 12 times 3, close parentheses, arrow over, and then close the big parentheses. So when I hit enter, I get a payment. Hopefully I typed it in correctly. 6, and when I round it to 2 decimal places, that's what the payment I get. Here on this one, I'm going to try this one now. First I got to type in a fraction, 20,000 times 7.15%. Should have did all these ahead of time. Divided by 12. Take it to the bottom. Parentheses 1 minus parentheses 1 plus fraction 7.15% over 12. Arrow over, close that parentheses, raise it to a power parentheses negative 12 but it's times 5 here. We're doing this car loan over 5 years. Close that parentheses. And here the payment is $397 and 44 cents. Okay. Find the monthly payment and the total interest for each loan. Well, we know we paid here. We paid 3 years, which is 12 months each year. We made 36 payments. Do you see? 3 years is 36 months of payments. So there we did 36 months of payments. Here we did 5 years of payments times 12. We did 60 months of payments. So if I multiply this number by, first let me do the first one, $614.35 times 36. I paid a total of $22,116.60. Here, I made a payment of $397.44 times 60 months, 5 years, and I paid $23,846.40. So it says, how much interest did I pay? Well, if the car loan was $20,000, then if I subtract $20,000 from this, I get $2,016.60. This was my interest I paid, the amount extra from the car loan. The car cost $20,000, but I had to pay $2,116 extra because I borrowed their money. Here, if I subtract $20,000, I paid $3,846.40 extra. Do you see? This is the interest. That's the amount above the car loan that I'm paying this company to borrow their money. I'm still supposed to go to page 121. Let's see. There's something on page 121. And I will try doing that here in a second. I'll be right back. All right, let's do this last problem, A, B, C, D, and E. Find the down payment. So here's the price of a home, $215,000, and they want 20% down. So to find 20% of 215,000, just multiply it by 20%. And when you put it in your calculator, you get 43,000. So to buy a $200,000 house, you had to put 43,000 down. So if you give them $43,000 for this house, then the amount that you're going to finance is $215,000 minus your $43,000 you're going to give them to put down. So you're going to get a loan from the bank for $172,000. This is how much you're going to finance. This is the loan for your house because you gave them $43,000 as 20% down. Now they're going to ask for how much must be paid for the 2 points closing. Well, points on closing is a fee. They charge you to do all the paperwork and give you the loan. It's a fee. 2 points is 2%. So it's 2% of the loan. The loan is $172,000. And you have to give them 2% of that just to do the loan. You still owe 172, but the 2% is a fee for them to do all the paperwork. What? Times 2%. So in order for them to do the paperwork on your loan, and loan you the money, you have to give them an extra $3,440. So you're giving them $43,000 down, and then you're going to give them $3,440 for the loan. You still owe $172,000. So now we want to find the monthly payment. And this monthly payment is just on the 172, what you're paying the bank. So look at your formula sheet and the one that says payment. It's very similar to the one buying a car. It's the same thing as a house because you're doing 12 payments a year. So to find the actual payment that you're going to do on the house, we're going to use that same formula. The payment equals the principal value, the starting value, times R divided by N, all divided by 1 minus 1 plus R, 1 plus R over N, raised to the negative N times T. And I always put my power in parentheses. So let's fill this in. Principal, we're starting off with a $172,000 loan. $172,000 loan is their principal times the interest rate we're getting for this. I don't remember. I got to go back up to the top to look. It says 5.8% at 30 years. Times 5.8%. N is 12 because we're making monthly payments on a house the same as a car. 5.8%. That's a percentage symbol. Over 12. And then we have 1 minus parentheses 1 plus 5.8% over 12 raised to the negative 12 times 30 years. House payments are normally 30 years. You can't, if you can afford 15 years, do that. So I'll put this all in my calculator. I hit a fraction first, parentheses 172,000 times 5.8% divided by 12. Close that parentheses. Start a new parentheses. 1 minus parentheses 1 plus fraction 5.8%. 12. Raise it to the power. Oh, lordy. Negative. That's not right. Raise it to the power of negative 12 times 30. Close parentheses. Arrow over, hit enter. I get an error. Okay, I'm going to try one more time. 172 times 5.8% divided by 12. 1 minus 1, parentheses 1, plus 5.8% over 12. Close that parentheses, raise it to a power negative 12 times 30, close parentheses, and hit enter. And I definitely got that wrong again. Okay, so I'm not sure, but this is what I got. If you got something different, that's okay. It should be close to this, 831.33. That's what I got. So the payments for 30 years are $831.33. Okay, so I did it again. I must have typed something in wrong because I got $1,009.22. So this looks correct. I did this twice and this is what I got. So I'm going to make $1,009.22 payment over 30 years. So I'm going to pay $1,009.22 12 times a year for 30 years. Do you see? That's how much I'm going to pay the bank altogether. Take this number and multiply it by 12 and then multiply it by 30 years. In other words, 360 payments. And I would have given the bank $363,317.48. If my loan was only for 172, but this is how much I gave the bank. It says, so how much interest did I give them? Well, interest is everything more than the 172 that I got the loan for. So just subtract 172 from this number, 172,000, and this is the interest, $191,317.48. This is the interest. This is how much you had to give the bank extra. You gave the bank $363,000 for a $172,000 loan. That's the price for borrowing money. And that was the end of the test review. I hope this review helped you. The hardest part is typing these things in the calculator correctly. Hope you guys have a good day.